Hi everyone, welcome back to the second video of this system design series. In this video, we will cover scalability, horizontal scaling, and vertical scaling. What is scalability? Scalability, if you see, is made up of two words, scale and ability. That is, ability of something to scale. What is scale? Scale means to adjust as per the demand. Demand can either grow or reduce. If we look at the definition, scalability is the property of a system to handle a growing amount of work by adding resources to the system. And if you look at the other definition, scalability is the measure of a system's ability to increase or decrease in performance and cost in response to changes in application and system processing demands, which means as the processing demands changes, that is either increases or decreases, scalability is the ability of the system to adjust according to the demand so that it can increase the performance or decrease the performance and automatically adjust the cost. Let's take example of e-commerce website again. During normal days, let's assume there are 1,000 customers visiting the website daily. But on occasions like sale, the customer number increases drastically, especially when the sale starts, and the applications are able to handle all the load without any issue. How does that happen? Well, there are two possibilities. First, there are many servers running 24 into 7 to handle millions of users. Even if the count of customers visiting are just a few thousands, but the servers are running so that they can handle millions without any change. This doesn't sound very pocket friendly, right? And definitely not a thing someone would like. What's the second option? Second is to scale the system by adding resources dynamically as the demand increases, which in fact is cost effective. So everyone's happy. When the demand increases, you add more resources to cope with it, and when the demand reduces, you simply reduce the resources. And that's exactly what stability is, to adjust as per the demand. Why is scalability so important? People hate lag. People don't want to wait. So latency plays a very significant role in determining whether a business will lose a customer or not. As businesses grow, the demands of user will also increase, right? Because number of users are increasing. And for an enterprise to keep up with its growth rate, it needs to ensure that its system are scalable. When the number of people using the platform increases, the load on the server will definitely increase. And for a business, it's very important to ensure that its server are able to handle that load. A system with poor scalability can increase labor cost and response times, and even compromise the quality of a product or service. And that's why scalability is so important to provide good user experience and handle the demand as the user base grows. We talked about increasing the resources in case of scalability. So what are those resources? So those resources can be disk input output, CPU, network bandwidth, or memory or storage. So basically there are two types of scaling, vertical scaling and horizontal scaling. So if you see at this representation, in case of vertical scaling, we have one single system, and in order to scale it, we are adding more resources into the same system, and hence the size of the system is growing in this representation. So in vertical scaling, we if we have to increase the RAM or CPU power, we just add more RAM to it, we add more CPU to it, and hence our system has scaled. Now it has more capacity and it can handle more users. But in case of horizontal scaling, instead of making changes to the existing server, we simply add more servers to it. So if you see, we in this representation, we are simply increasing the count of servers, and that is horizontal scaling. Now let's cover each of them one by one. In vertical scaling, we upgrade the capacity of the existing machine or we replace it with a new machine. So that is vertical scaling. We can add more powers to our machine by adding better processors, increasing the RAM, or making other power adjustments. So we simply replace the existing machine or add more resources into the same machine. Let's take over a look at advantages and disadvantages. So what are the advantages? So it has fast response times as there are no synchronized nodes that communicate with each other. So because we have a single server here, this single server doesn't have to communicate with any other server, right? So in this case, the response times are fast because the nodes don't have to synchronize with each other for any type of communication. Second, upgrading a specific components costs less than purchasing a new server. So whenever you want to upgrade something, you can simply swap the old component with a new component. You don't have to purchase a complete new server. So for example, if you want to upgrade a RAM, you can take the old stick out and put a new stick in. You don't have to purchase the complete system like motherboard and all the other components that are involved with it. So in that aspect, it is very cost effective. Third, everything runs on a single node, which leads to better data consistency, and there is no need of load balancing. Because we have a single server here, we don't have to worry about load balancing, and it has better data consistency. Again, because we don't have to maintain the consistency of data between multiple nodes. And we will cover load balancing in the next video. Now, moving over to disadvantages. There is a limit to how much a single machine can scale, right? You cannot add infinite amount of RAM, infinite amount of storage or processing power into a single machine. There is a hardware limit for everything. So in vertical scaling, there is a limit up to which you can scale. Higher possibility for system downtime. Because you have a single node present here, and if that single node goes down, you will have a downtime because you rely completely on that single server. So that is a major disadvantage. And if you see third and the most important, you must take the machine offline to perform the upgrade. Whenever you want to make any change to any of the processing power, RAM, storage, anything, you will have to take your system down. Let's take an example. You have a home computer, you want to change the RAM. You cannot pull out the RAM from a working laptop, right? The system will crash definitely. So you will have to take the system offline before you make the change to RAM. Making the system offline means downtime, which is definitely not a very good user experience. Next up, we have horizontal scaling. In horizontal scaling, we enhance the power of the server by adding more machines to the network. The machines share the processing power and memory workload across the multiple devices. So we simply add more instances of server to the existing pool of servers and distribute the load among all the servers. In this approach, there is no need to change the capacity of the existing server. So we have one server that is running, keep it as it is. When we want to increase the capacity, add more loads to it. Also, in vertical scaling, there is no downtime because we are not removing the existing machine or we are not turning it off. Most organizations choose this approach because it includes increased input-output concurrency, reduced loads on existing node, and it also increases the hard disk capacity. Horizontal scaling can be achieved with the help of distributed file system, clustering, and load balancing. If you see at this representation, as the count of users increase, we are adding more nodes to it. And as the count decreases, we are simply removing the nodes. We also have a load balancer here. And all the servers, they are accessing a common database because in this case, we have to maintain data consistency. So let's assume we sent a request and that was handled by server A. And if the change is stored locally to server A, whenever you try to access the same data again, and let's assume that that request went to server C, because the data is stored in server A, server C isn't aware of it. So, and that will give you incorrect data. That is why the machines need to share a common database so that they can maintain data consistency. Let's talk about advantages and disadvantages. So, advantages first. Systems that scale out have no scalability cap. So there's no limit on how many devices you can add to the existing pool of networks. The only limits are your budget and the capacity of the data center. If that's not a constraint, you can keep on adding as many devices as you want. It has easier to run fault tolerance. The system does not go offline during the scaling process like explained earlier, and big players like Google, Yahoo, Facebook, they prefer this method of scaling. What are the disadvantages? Because we have multiple servers here, we have to distribute the load among all these servers, and that's why we have to install softwares for load balancing. Data consistency is concerned due to cross-server communication. We have to make the data consistent, like I explained, right? Because one request could have been handled by server A and another could have been handled by server B. And there is a possibility that one single user can send multiple requests at the same time, and all these requests can go to different servers. So there can be situations when the servers have to communicate between themselves to give you the right result. And that's why data consistency here becomes a concern. Each new server requires more space, right? In case of vertical scaling, in the same system, we were adding more resources. But in this case, we are adding the complete new system. And with each system, we have to add more power, we have to supply more power, and we have to provide more cooling to it. And because of that, the cost increases more. Node-to-node communication slows down performance in a poorly optimized cluster. Because there is a possibility that nodes have to communicate amongst themselves, and if the cluster is not properly optimized, it can lead to performance issues. So these are some of the disadvantages of horizontal scaling. Now let's compare both vertical scaling and horizontal scaling side by side. Okay. First point, how the scaling works. So we add more servers to the existing pool of machines and we have scaled up. In vertical scaling, we either upgrade the existing machine or replace it with a new one, but we will have to maintain the count one. Second point, process complexity. In horizontal scaling, the complexity is much more because it requires data consistency and we have to add load balancers to it. But in vertical scaling, we turn the old machine off, make changes, turn it back on. Third point, overall cost. It is very high in horizontal scaling because we'll have to add new servers every time. But in vertical scaling, it's very low because we only have to replace the components. Single point of failure in horizontal scaling because we have multiple servers running parallelly, so that's not a case. But we are dependent on one single machine in vertical scaling, so we have a single point of failure there. Data storage. We can distribute the data across multiple nodes in horizontal scaling. We have to do that to maintain data consistency. But in vertical scaling, all the data lives on the same server. Data consistency. It becomes an issue in case of horizontal scaling because we are interacting with multiple nodes. Again, in vertical scaling, because it is one single server, data consistency is not an issue. An upper limit for scalability? In case of horizontal scaling, no, there is no such limit except the budget constraint and the size of the data center. We can keep on adding as many machines as we want. But in case of vertical scaling, yes, each machine has a threshold for RAM, storage, and processing power because there can be limited slots available in each machine and the hardware support. Downtime during scaling. In horizontal scaling, we don't have any downtime, but we do have one in vertical scaling because we have to take the machine offline. Risk of unused resources are low in horizontal scaling, but in vertical scaling, they are high because let's say you added more capacity to an existing machine and the load reduced. So you'll have to again take the machine offline and then reduce it. But that might not happen very frequently, right? So in that case, you will be running the server with high resources, and that in that case the resources will be wasted. Required code rework? Yes, in horizontal scaling, we'll have to write our code in such a manner that it can work across multiple systems in a distributed way. But in vertical scaling, that's not a concern. Our code will run on one single machine. Ability to scale down? Yeah, we can simply take the servers out and horizontal scaling is scaled out. But in vertical scaling, we'll have to take the machine offline and remove the components. Now, the most important question, which one to choose? Both scaling out and up are worthwhile strategies, and both have different use cases. So we cannot say that horizontal scaling is better or vertical scaling is always better. It all depends on the use case. So let's compare some points. Performance. Vertical scaling is simpler because if one single machine can meet our requirements, then what's the need of adding multiple machines? Whenever we are falling short, we can upgrade this one single machine and our problem is resolved. Size of current instances. If we rely on smaller instances, scaling vertically before scaling out is likely a better long-term strategy. If we already have one small server, it's better to increase the capacity of that server before we try to replicate it. Flexibility. Scaling out is the way to go. If you require the ability to adjust IT resources to the current load dynamically. Scaling out means horizontal scaling. So it says that if we want our resources to adjust dynamically as per the load, then we should prefer scaling out, and that is horizontal scaling. Upgrade regularity. Scaling out is more challenging to set up initially, but the model simplifies every following expansion. So it means that horizontal scaling is difficult to set up initially because we have to take care of load balancing, then data consistency. But in future, whenever we want to add the resource or remove the resource dynamically, it becomes very simple. But on the other hand, in case of vertical scaling, because there is downtime involved whenever you want to make a change, that is not very feasible because we won't make our application go down for making change, right? That won't be a good thing. Scalability cap. Scaling up always has a set threshold. So go with horizontal scaling if you want to avoid a cap on scalability. Horizontal scaling has no limit, like we discussed. Redundancy. If your app or workload cannot tolerate downtime, horizontal scaling is the better option as it doesn't have any single point of failure. Geographical distribution. Hosting an entire app in one server is sometimes not an option. And that can be because to reduce local latency or meet compliance rules. So let's say our server is hosted in US and we are sitting in India. Let's assume we keep a server in India also. So, and whenever we make a request, that request will go to India's server and we will get our response much faster and that will have reduced latency. So, to reduce latency, we can distribute the servers geographically in horizontal scaling or to meet compliance rules. So, certain countries might have rules and regulations related to data. So, to follow that also, we can geographically distribute the server. Cost. Vertical scaling is cheaper to perform and maintain than a horizontal scalable set of nodes, right? Like we discussed. Because adding more nodes involves more cost than upgrading a single node. So that's it for this video. Thank you so much for watching. Stay tuned for more.